Hi all, today we will discuss about the basic elements of instruction execution cycle. One is micro operation and macro operation, and we will see how an instruction is executed. There is a special concept called instruction cycle. Before going to discuss about these things, one should remember that instruction is the basic element of execution in computers. That means it is the one which has to be executed by CPU, and the instruction has to be provided by the user. The user provides an instruction, and this it is the responsibility of the CPU to execute that particular instruction. When I say instruction, as a as we all of know, instruction contains opcode and operands. So as of now we are assuming that the basic element of a program is instruction from user point of view. So from user point of view, the basic element of execution is instruction in a program. But for the convenience, this instruction is further divided into some small operations that can be performed within the CPU. That means, again, when the instruction decoder in control unit decodes that the particular opcode has to be performed, then this task of executing an instruction is divided into some number of small operations. So when someone says instruction execution, there are few basic operations that has to be executed within that instruction. So broadly saying, instruction execution task is divided into small sub operations. We will discuss in detail about that. In that, the first one is micro operation. The micro, as the name says, the meaning of micro is small. So the micro operation means a small operation that can be performed within instruction execution. That means when instruction execution task is divided into smaller groups, small elements, or small sub operations, then when the task of instruction execution divided into smaller operations, each operation is referred as one micro operation. For example, maybe loading the address into PC is one operation, one small micro operation. So we should know in detail about the micro operation. So as of now, we know that when user develops a program contains a group of instructions that are required to execute. But further, the instruction execution is divided into different tasks, and also this instruction is divided into small operations, sub operations, or you can call it as small operations. They are nothing but micro operations. So simple digital systems are frequently characterized in terms of the register they contain and the operations that they perform. So any digital computer is characterized by two things. One is the registers they contain, how many registers they contain. Remember we discussed simple accumulator based CPU where the important register is accumulator. Likewise we have general purpose CPU organization where we have n number of registers, and sometimes we may use stack organization based CPU where everything we do using stack, a special data structure called stack. So it is important to know, it is important to have how many registers a particular digital computer contains, and second one, the operations that they perform. What is the smallest element, smallest operation that that particular computer can perform? All of you know about registers. Now we will discuss about smallest operations. So those smallest operations are called micro operations. The smallest operation that can be executed within CPU is called micro operation. And remember where this micro operation comes from? They are divided from the instruction itself. So the instruction contains some, or instruction is divided into some sub operations. The operations on the data in these registers are called micro operations. Simple to say, micro operations are the smallest operations that can perform some operation on the data stored on a registers. So with this you should remember that PC program counter should be loaded with a starting address of an first instruction. Remember in computers, when you want to execute a particular program, in that first instruction address has to be loaded in program counter. This is one micro operation, and it has to fetch that program counter contains some address. So we have to go and fetch that instruction which is present at the memory location specified by this program counter. So it is one another micro operation, and incrementing a program counter value so that it points to next address, it is another kind of micro operation. Likewise, whatever operation that you perform on the data in a register is called micro operation. So micro operation means it is the smallest operation that can be performed on the data stored in a register. And the functions built into registers are examples of micro operations. And you know, with register, example for the micro operations are such as shift, load, clear, transfer, increment. So these are the smallest micro operations that you can perform on the data stored in a register. Next we have macro operation. Macro operation means the set of micro operations is nothing but macro operation. It is so simple. Macro operation means set of micro operations are called macro operation. I hope you should understand. Now set of macro operations is nothing but one instruction. Now I hope you should understand an instruction is divided into set of some macro operations, and these macro operations are further divided into micro operation. So you should understand the relation between these three. Micro operation macro operation and micro operation, macro operation and instruction. So if this is my instruction, it is further divided into macro operations. It is further divided into micro operations. So macro operation is nothing but a set of micro operations. Statements. Macro operation contains statements that executes with many control functions, and whereas micro operation is a single operation, single instruction. Statement executes with one control function. So we will see what is this control function meaning. Here we have, remember, macro operation has n of more than one control function, whereas micro operation has only one control function. We will see what is that uh, control function. Time being, understand that control function is something related to execution of an instruction. Now we move on to the very important topic in this episode, that is instruction cycle. So instruction cycle, as the name specifies, instruction cycle. So the instruction cycle means it's sometimes called fetch and decode cycle, but you know the meaning of an instruction. Instruction is nothing but is the uh, is an instruction is developed by the user to perform some operation. So the on the data. So the instruction cycle means something which gets repeated. That means this is called instruction execution cycle. How instructions are executed within CPU. What are the steps? What are the different phases in executing an instruction? And remember, there won't be a single instruction. The program contains n number of instructions. So the procedure that is followed to execute one instruction is repeated for all the remaining instructions in the program. So when you repeat something, you call it as a cycle. For that reason, we have this concept called instruction cycle, or this is in fact instruction execution cycle. How instructions are executed uh, within the CPU. Remember, we discussed this topic when we were discussing about special type of registers in simple accumulator based CPU. You should remember that we use some special registers. Before discussing this instruction execution cycle, I will remind you some basic concepts like program counter, what are the functionalities of some special purpose registers within CPU. Remember, CPU is broadly divided into two parts. One is storage unit and other is data processing unit. The storage unit contains primary memory and secondary memory. Secondary memory is the largest memory and permanent memory but slow memory. Primary memory is a small memory, relatively small memory. Relatively means compared to secondary memory, it is relatively small but fast when it comes to speed, and it is directly connected to data processing unit in CPU. So the data processing unit of the CPU directly interacts with primary memory, not secondary memory. What if it requires a memory word? Remember, memory word means when divide memory into different memory locations, each memory location contains a specific word data, that is called memory word. If some data stored in secondary memory is required by this data processing unit, then the data processing unit will look in the primary memory. If it is not in the primary memory, then you have to fetch uh, the data from secondary memory and place in the primary memory. So this is about storage unit in CPU. And likewise, there is other part, data processing unit. The data processing unit contains two major elements. One of the important one is control unit, which sends some control signals to all the remaining all the remaining units like input device. The control unit will send signal to the input device, output devices, storage unit, and within that data processing unit there is another special element called ALU, arithmetic and logical unit, which is responsible for executing any mathematical operations, arithmetic and logical operations. So this is the CPU organization. It contains the storage unit and data processing unit. Storage unit contains secondary memory, primary memory. Data processing unit contains control unit and ALU. Control unit is responsible to control all the functionalities of the parts of the devices or units in the CPU. So the control unit, we know that this is the CPU organization, and we also discussed some special type of registers like program counter, which is program counter is a special type of register. Now what is a register? Register is a special memory elements, group of memory elements where the intermediate results or temporary data being stored. So there are different special types of registers, like program counter is one register. All of you know that program counter is the register which contains the address of the next instruction to be executed. And there is a IR register, instruction register. It contains the current instruction being executed by CPU. And there are two special registers related to memory, that is memory address register and memory data register. Address register should contain the address of the memory location where you have to perform either read operation or write operation. And memory data register can contain a word that has to be written into the memory or that has been fetched from the memory. And there is accumulator is a special register. And remember, this IR and PCR part of this whole control unit. This AC accumulator is a special type of register specific to ALU. ALU is the one which is performing arithmetic and logical operations. So while performing its operations, it may require a it may require to store the temporary results in a special register, that is nothing but accumulator register. So this should have all these things. We should have some this is the prior knowledge or the basic knowledge to understand the instruction cycle. And whenever we say processor, remember, whenever we use the word processor, the processor means it is a it especially refers to the data processing unit of the control unit, that is control unit, data processing unit of the CPU, that is control unit, ALU, and some special type of registers. These are called instruction cycle. So instruction cycle, sometimes also called fetch and decode cycle. So fetch is the word related to memory. So remember, when we discussed the simple accumulator based CPU, we used the term fetch. Fetch an instruction from memory. Fetch the data from the memory. So fetching means something taking from the memory. And decode. And decode is something related to control unit. So the control unit, after fetching an instruction, control unit, what it does, it has to decode a part of the instruction. Which part of the instruction? Remember, instruction contains two parts. One is opcode and the second one is operands. So which required to be decoded, opcode part or operand part? Of course, it is the first part, that is opcode. Operands doesn't require any decoding, but opcode stands for operation code and it requires to be decoded. What is meant by decoding? Remember, the opcode part contains some number of bits. So if it contains 3 bits, you can perform, there can be possible of 8 different operations. Likewise, so these one, which of these 8 operations are required to perform, that has to be decoded by a special unit in control unit, that is instruction decoder. So the important part in instruction execution is fetching the instruction from memory and decoding the opcode part of the instruction. So this has to be repeated several times. And of course ALU performs an execution, right? Execution means it performs mathematical operations. So fetch, decode, execute, store. We will see the steps one by one. So the instruction cycle, sometimes called fetch and decode cycle. It is the basic operational process of a computer. Remember, when we discussed program execution, executing a program means executing all the instruction in the program. Executing all the instruction in the program means executing instruction one by one. That is fetched from memory. That is called stored program concept or sequential program execution. And this instruction execution repeats for all instructions stored in a computer. It is the basic operation process of the computer in which a computer retrieves a program instruction from its memory, retrieves or fetches the program instruction from its memory, that determines what actions the instruction dictates and carries out that instruction. Next we see the components of an instruction cycle. The components are program counter. Already know program counter is a special type of register which contains the address of the next instruction to be executed. Next we have memory address register. So memory address register is a special type of register which contains, see, whenever we say memory, there are two operations with respect to memory: read operation and write operation. The read operation, if you want to perform a read operation from memory, so the program counter is a special type of register that is used to store address of next instruction to be executed. Next we have memory address register. So the memory address register whenever we say memory, we can perform two operations, read and write. For read operation, it is required to go to memory and fetch a particular memory location, and remember that memory location will have an address, so that address has to be stored in present in memory address register. So if you want a particular memory location to be read from memory, you should place an address in the memory address register. Next we have, if you want to perform a write operation. So again, even if you want to perform a write operation in the memory, you should know to which memory location the data has to be loaded. Writing means something storing the data in a particular memory location. In a particular memory location means that particular memory location will have an address. So in fact, in memory, you have to find out the empty memory location where we can place the particular word. So the address of that particular empty memory location has to be present in the memory address register. So if you want to perform read operation or write operation, it is required to have address to be loaded in memory address register. Next we have memory data register. As the name specifies, memory data register is a special type of register which is related to memory. So again, for read operation or write operation. For read operation, memory data register doesn't contain any data. It will go memory address register contain the address, memory data register contain empty. They go to memory, see the address of the memory location present in this MAR, and if that memory location contains any data, that will be loaded into MDR, memory data register. It's like a carrier to transfer the data between memory and registers of the CPU. See, the data transfer means, remember, if you want to fetch the instruction is which is stored in the memory, again that has to be placed in the MDR. From MDR it will goes to IR, special type of register. With respect to write operation, MDR contains a word that has to be loaded into memory location. So this is about memory data register. Next we have instruction register. So instruction register is a special type of register which contains the current instruction that is being executed. Next we have control unit. All of you know that control unit is one of the key component in CPU which sends some control signals control signals for performing micro operations. So when the data in the program counter has to be incremented, it will decide by control unit what operation ALU has to perform. The control unit only sends a control signal. For when the input device sends the data entered by user to storage unit, that is also controlled by control unit. So the control unit basically controls everything in the computer. Next, ALU. ALU stands for arithmetic and logical operations. It performs arithmetical and logical operations like addition, subtraction, multiplication, division. So now we see the steps of the instruction cycle. So the instruction cycle contain, there are different uh, steps are there, we will discuss. The first step is fetch the instruction. In instruction cycle, this is step 1. What is that? Fetch the instruction. Fetching means something related to memory. From where you can fetch the instruction? First, you should know that all the instructions entered by the user using input devices are going to be stored in the memory, that is in the secondary storage device. From secondary storage, that will be transferred to primary storage. So now instructions and data are in the memory. Fetch that instruction. Who will issue? The control unit will send a control signal to fetch the instruction. Of course, the memory contains different memory location, and when you say fetch an instruction, which instruction? That next instruction to be executed. Who will decide the next instruction to be executed? Program counter. So when you start a program execution, the address of first instruction, see, the program is stored in the memory. Program means all the instructions related to program are stored in the memory. In that, first you should execute first instruction. In case of C language, you should, when you read, you should know the main. So this is first instruction. This instruction might be stored in some memory location. Let's assume memory location word 1 in the memory. So this 1 should be loaded, initially loaded with the program counter. This is called one micro operation. So now everything is ready. Now the control unit knows that PC is loaded with the address of the first instruction to be executed. Now it issues fetch, go and fetch the instruction. So this is the step 1 in instruction cycle. What is that? Fetch the instruction. Now where is the instruction? This instruction is stored in the memory at location 1. So now the PC contain the value 1, that is address of the instruction to be executed. So transfer this PC to MAR. So the MAR contains 1 now, and you know that you have to perform a read operation. That read operation, what it does, the address present in MAR is verified with the, is there any memory location in the memory with that address? Yes, we have, this is the memory location. So this main is transferred to MDR. From MDR it is transferred to IR part of the instruction. So now the instruction, that is main, is in IR. So this is called fetch. So fetch means ultimately what's happening, the instruction that is present in the memory is shifted to the instruction that is in the memory is transferred to IR, special type of register called instruction register. This whole process is called fetch the instruction. This is the first step in instruction cycle. Fetch the instruction. The next instruction is fetched from memory address that is currently stored in the program counter. So the next instruction fetched from the memory address, and that address is present in the program counter, and store that instruction in IR. This is about fetch. Next we have decode instruction. The decode instruction, what it contains, now the instruction is at IR. Let's assume our main is our IR. Now the instruction is at IR. The IR contains instruction maybe, let's assume, add a comma b is the instruction. So this is my instruction, add a comma b, that is stored in IR. Now this instruction contains two parts. One is opcode, another is operands. This opcode has to be sent to control unit, and control unit contains a special command called instruction decoder, which will decode the particular instruction and decodes the particular instruction so that which operation is required to perform is decided by ALU. So the control unit decodes the instruction. That is the second step. First is fetch the instruction from the memory. Second one is decode the instruction. In fact, it is not decode the instruction, decode opcode part of the instruction. So it is really important to understand what is the meaning of decoding and why it is used, because everything is mentioned in terms of bits, remember, in computers. So when instruction register contains add a comma b, add is represented with some n number of bits, let's assume 001. This has to be decoded so that which operation is required to perform. See, we are human beings, we are able to read the word add and we understand that add means addition, but computer doesn't identify this add. How it can identify? Only by decoding. That's for that we have a special decoder in the computers, in its control unit. So decode the instruction means during this cycle the encoded instruction present in the IR is interpreted by the decoder. And next we have so once the instruction opcode part is decoded, so this is my IR, add a comma b, this is opcode, and these are called operands. This add is sent to control unit, which contains instruction decoder, and it will decode and instructions, and it will send in some instructions to ALU to perform some operations. So it now ALU understands that it has to perform addition operation. So now ALU has to perform this addition. Okay, ALU identifies that it has to perform operations, but on what? It requires some operands that they are again present in the instruction register, that is A and B. A can be some memory location, B can be memory location. That means address of memory location. Address of memory location 1, address of memory locations. So now you understood that again this word is present in the memory. So again we need to perform fetching the data. So first you should know that AB can be registers or value or some address of a memory location. Ultimately we have to identify where the value is, whether AB refers to some registers which contains the data, or AB refers to that address which is stored again in the register. See, AB can be registers, but they may contain only address of the memory location where the actual value are stored. or AB are directly registers which contain some data. AB are some constants. So this is so now we should finally conclude the address of the values to be added. This is called read effective address. So read effective address means direct memory instructions, nothing is being done in the clock pulse. Indirect memory instructions, the effective address is being read from the memory. Direct memory instruction means the instruction itself contains the data. In this case, nothing is required to perform. But when it comes to indirect memory instruction, the effective address is being read from the memory. That means, see, the value can be in the memory. Let's assume if I want to add a comma b, and a is 10, b is 5. So the a is, let's assume a is one address 1 2 3 4. A contains 2, b contains 3. What are 2 and 3? They are the address of the memory locations. So first again we have to issue a read operation for fetching, or the second case would be simple case, a and b are the registers, special type of registers within CPU which contains directly data 10 and 5. So these values has to be fetched. Need not to fetch because they are not in the memory. The values in that register can directly be used by ALU, or AB or some like constant. A comma B can be like some 10. Only ALU be fetched from the memory. It is required to fetch from the memory. So this step is called read effective address. Read effective address is something related to find the address of operands. Simple. You have to evaluate address of operands because ALU knows that it has to perform addition, but if for performing addition the ALU requires values in special register AC and B. Let's assume AC and some BR. Accumulator should contain 10, BR should contain 5. These values may present in the memory location or they can be in the register. Next we have execute the instruction. Now everything is ready. ALU knows that it has to perform addition, and ALU has two special registers. Let's assume AC and BR. They are also loaded with the value 10 and 5. Now only the pending part is ALU has to perform the operation called addition and store the result back in 15 if it is an accumulator based CPU. So what's happening here? Execute the instruction. The control unit of the CPU passes the decoded information as a sequence of control signals to relevant functional units of the CPU to perform the action required by the instruction. That means now everything is ready. Ultimately, ALU has to execute an arithmetic and logical operations. It has been instructed by control unit what operation is required to perform and on what operands. Everything is ready. Operands are ready. Operation, it know what opcode. Just execute the instruction. So these are the steps. First is fetch the instruction, decode the instruction, read the effective address, and execute the instruction. And the next last one is store the result. You can say the last step is store the result. maybe in the memory. So when somebody says what is an instruction cycle, first you should say fetch cycle, decode cycle, execute cycle, and store cycle. So fetch, decode, execute, and store. Fetch means fetching an instruction from the memory. Decode means decode opcode part of the instruction. Execute means its operation performed. Some arithmetic and logical operations is required to perform by ALU. But before decoding and executing, you have to read effective address of the operands. You have to see where the operands are present, and finally store the result in memory. So this is the 4 steps. Remember, it is very important to understand the instruction execution cycle. It is fetch cycle, decode cycle, execute cycle, and store cycle. These are the steps in instruction cycle: fetch, decode, execute, and store.